Greetings, everyone. It is my absolute pleasure to welcome you all to what is a unique initiative that we've curated with Corning India. Corning, as many of you would know, is one of the world's leading innovators in material science with a 169-year track record of life-changing inventions. Corning's foray into environmental clean air technologies began when the company invented the cellular ceramic substrate more than 4 decades ago in order to help automakers meet the US Clean Air Act regulations. Today, they are as committed as ever to researching, developing, and engineering environmental products that improve the quality of the air we breathe. Corning creates ceramic substrates and particulate filters that form the core of world-class pollution control systems, from light-duty passenger cars to heavy-duty trucks and construction equipment. We started discussing the possibility of creating an event around the National Pollution Control Day on December 2nd, and eventually got around curating a 4-part series on innovations in clean air technologies. The objective of this series is to drive discussions around emission norms in India and talk about Corning's environmental technologies, both in India and global markets, with an aim to educate the relevant stakeholders in the Indian automotive industry. We kick off the series today with this dialogue with Dr. Willard A. Cutler, Division Vice President and Commercial Technology Director, Corning Environmental Technologies. Following this dialogue, we will move to 3 quarterly discussions in March, June, and September next year that would include masterclasses on clean air technologies by Corning and panel discussions. Ladies and gentlemen, we begin today's dialogue with Dr. Cutler, who is currently Division Vice President and Commercial Technology Director, responsible for the customer-facing technology for Corning's environmental technology business. Dr. Cutler has worked for Corning for more than 30 years in various research, product development, commercial, and leadership roles in Europe and the US. He has successfully delivered many new products to the market and has served for 8 years on the board of Cormetech Incorporated. Dr. Cutler holds a PhD in materials from the University of California, Santa Barbara, and a bachelor's degree in material science and engineering from the University of Utah. He has been awarded 18 patents and has published a number of scientific papers. Now, before we start, a reminder to all our participants today that you have an opportunity to interact with Dr. Cutler. So if you have any questions for him, do share those using the Q&A box at the bottom of your screens. Dr. Cutler, welcome, and we'd like to start our session today.
Oh, thank you very much for taking your time, and appreciate the opportunity to talk.
So Corning's first foray into environmental clean air technologies started with a cellular ceramic substrate 4 decades back. So Dr. Cutler, talk to us about the innovations in the area of clean air technologies in recent times, and how have they positively impacted the quality of air we breathe?
Thank you. So, maybe just a little anecdote about the invention more than 4 decades ago, as you say. It was really something that wasn't expected to last. The development of the cellular ceramic, which has become the heart of our catalytic converter, which is, the ceramic device that you see here. The original factory, was only depreciated over 5 years because the auto companies said that they would be able to clean their engines sufficiently so they wouldn't need pollution control devices. And it's really been fascinating to see that, the extent to which automotive OEMs have been able to clean engines, but the corresponding need to continue to have less and less pollution, which has resulted in advances in technology. And so typically what happens is a new regulation comes into play, and the existing technology is insufficient to meet the new regulation. And so, car companies and truck companies then come and say to us as suppliers, hey, how can you help us to meet regulations? And so we typically partner and work to develop the technologies that then allow us to reduce the gaseous emissions or the particulate emissions that allow for the new regulations. So we have a large group of scientists and engineers that we then expose those material scientists and process engineers to these problems, which then develop the next set of products that can be used as a tool to reduce pollution.
Right. Now, how do you view the transformation in the mobility ecosystem world over, from internal combustion engines going over to electric vehicles, and other alternate greener propulsion technologies in the future?
Well, I think it's a pretty complicated transition for particularly for OEMs, as they go from just a pure internal combustion engine, perhaps to a hybrid solution where you have both an internal combustion engine and a battery that can either propel or help, and then to the battery electric vehicle. And I think, as all of us are aware, there's a number of challenges making it completely to a battery electric vehicle in terms of the charging infrastructure and the range anxiety that people have and so forth. But I think it's a difficult challenge for OEMs because they have to have resources applied to lots of different applications. And I think it's an opportunity, though, to innovate. So as an example, on a hybrid vehicle, we have the pollution control devices for a traditional internal combustion engines, as well as the complexity on the electrification side. And the challenge is, in some cases, hybrids, most of the pollution that occurs in an internal combustion engine happens in the first few minutes. And in the case of a hybrid, which is turning on and off, that pollution burst happens several times. The other challenge typically is the hybrid engine, or these hybrids typically have smaller engines. Mm-hmm. And with the additional weight of the battery, these engines have to work even harder. And so as we move from pure internal combustion engines to hybrids, we need to make sure that we have the right pollution control devices to be able to control those microbursts of, say, particulates as well. So it's a really challenging environment, but it's full of opportunities for creative people. And I think none of us knows how smoothly this will go. Aspirationally, we would all love to drive battery electric vehicles, but I think there's a number of challenges to get from where we are today to where we'd like to be in the future.
Right. Dr. Cutler, the next question is, when you look at nations globally and overall environmental degradation, what are some of the most critical challenges that you face in the development of clean air technologies?
Well, I think the most difficult challenge for us is, while everybody's trying to meet, say, in a particular region, the same regulations, each OEM and perhaps each platform at an OEM is at a different starting point. And so you would like to think that for a particular regulation in a particular region, that everybody would use the same technology. But in fact, because of their starting point, they all have different space available in the engine compartment as well as under the car. They have different requirements in terms of integration and so forth. So just the complexity of OEM needs, even within a single OEM, can be quite challenging. I think with that said, India is quite fortunate in that most of the technology needed to meet both current regulations and future regulations has already been invented because of how regulations typically cascade from, Europe to other parts of the world.
So what has been your approach, Dr. Cutler, your approach to research, development, and innovation? And I'd like both a global perspective and a view on your approach for markets such as India, considering the value or cost-conscious mindset of customers here.
Yeah, so I think that's a great question because India is quite unique in terms of a number of things. India has a wide geographic diversity from quite cold in the north to warm in much of the rest of the country. And I think as we think about pollution control, you have the pollution bursts, I would call it, before the car is warmed up. But that gets even more difficult as you go to, say, colder climates or higher elevations. And so being able to deal with the worst case is perhaps the most challenging opportunity. So typically how things happen is in the US typically has the tightest gaseous emission requirements. And Europe has typically had the tightest particulate emission requirements. And so on a global basis, typically the innovations that we start with on the gaseous side are for the US market. Mm-hmm. And for the particulate side, it's been for Europe. Now, China is closely following Europe. And so when we come to a market like India, there's typically, we've typically seen and solved these problems for the US market, for the Europe market, and for the China market. And then our work is to then adapt that technology to the challenges of the Indian market. And of course, as you're aware, you probably don't have the high speeds that you would see on the Autobahn in Germany, as an example, but you have an incredibly diverse and different driving cycle, as you say, experience in Delhi, that we probably don't have anywhere else in the world. And so our approach would typically be to work with the local and global OEMs specifically for the Indian market. And then we also have run our own cars in India, where we will put on example technology from the US or Europe, and then we see how does it adapt or how does it behave in the Indian drive cycle and climate. And then based on that insight, we can help the Indian OEMs and global OEMs sort out how to adapt the technology to meet the Indian needs. As you indicate, the price point that somebody's willing to pay in Europe for pollution control is perhaps different than India. And so it's how do we, try to limit the cost addition that an Indian consumer would have to pay. So it's a little bit tricky, but it's rewarding to be able to see that sometimes these cars with the new pollution control are actually cleaning the air as they drive through the city.
Very interesting. Dr. Cutler, a follow-up question. What are some of the key differences when it comes to clean air technologies in a developing market, vis-a-vis a mature market? Do you approach it differently? Is there different materials that you use?
Well, fortunately, the same things that work in other markets that we have developed. And an example would be this little device here. You can see it kind of has a checkerboard pattern. And this is a gasoline particulate filter. We don't normally think of gasoline engines needing a filter because we normally don't see particles coming out like you would in a diesel engine. But a number of years ago, the Europeans recognized that even particles that you can't see, small particles that can get deep inside your lungs, can be quite harmful. And so they had proposed a regulation based on particle number to limit the number of particles coming out of even gasoline vehicles. Now, India is starting to adopt that in a few years, which is a good thing. But then the Europeans said, hey, we appreciate that you've been able to help us reduce our particulate from gasoline, but now we want to, they're currently working on Euro 7 regulations, which will reduce the particulate another 90%. And so, it is then incumbent on us to say, how do we change the base microstructure in order to capture even more particles? Maybe just an example, and this is a little bit hard to see, but you can see what looks like a sponge. It's a very porous structure, and this is the kind of structure that composes one of these walls in the filter. And as the need for higher and higher filtration efficiency comes up, then we change the microstructure of those walls in order to capture the particles. Now, of course, the thing that we don't want to do is make the engine work harder, because that is having an effect on both the fuel economy, perhaps, and the power of the vehicle. Right. So it's a really, as a material scientist, it's a fun challenge to be able to capture more and more particles without inhibiting the way the vehicle operates.
Right. I wanted to also understand from you, how do you see this, the regulatory scenario emerge in years to come, and what specific requirements do you see coming in?
That's a good question. I think with the advent of electrification coming, that it's likely that the regulations in Europe, which they're now working on proposing, Euro 7, may be the last set of regulations in, say, the European market. And typically, China would follow with China 7. And I suspect as India is going from, you made a great leap from BS4 to BS6. And I suspect that if that follows suit, that there would be a BS7, which may provide an opportunity to again decrease the particle output another order of magnitude. So I'm not sure after, say, Euro 7, China 7, BS 7, will there be additional regulations based on if the world is really going to electrification or not? Right. I think the great thing is we have the technology, regardless of where the regulations can go, to meet those regulations. It's just, how widely are people willing to go to reduce the amount of pollution? Maybe an example for you. In the US market, we looked at the pollution reduction if we chose an aggressive electrification scenario in the US. So today there's only a few % of electric vehicles in the US. I suspect it's similar in India. And of course, it's at least in the US, it's mostly rich people who can afford these vehicles. And so we said, well, what if we had 25% battery electric vehicles in 2025, which would be pretty aggressive for the US, and 100% electric vehicles in 2040? What would the particulate reduction be as a result of that aggressive electrification. And you might imagine, gee, it's going to, solve the world's problems. As we did the analysis, we were a little surprised that even going to 100% BEVs, the reduction in the particulate in tons was only about 17%.
Right.
And that's primarily because our vehicles are built to last for, a couple of decades.
Mm-hmm.
And so those vehicles sold between now and 2040 are going to be producing emissions for many decades to come. And so we saw that it will likely require not only electrification, but the need to continue to reduce, provide technologies that reduce the particulate now. And if we chose both electrification and improving our internal combustion engines, we could reduce the particulate emissions by nearly 50%. So it's, I think it creates some challenges for regulators.
Fascinating, fascinating. Dr. Cutler, what's your view on the future? How do you think clean air technologies would evolve in the mobility sector in the near to long-term future?
Well, that's a great question. I wish I knew the future. Maybe I wouldn't be a scientist, but I think I'm optimistic about the future. I think, as you saw from, we got a little peek of what it's like during the early days of COVID, when fewer people were driving. At least the clean air in many parts of our country, and I suspect in India as well, that you saw a glimpse of what's possible. And none of us like breathing polluted air. And so I think the technology exists to dramatically reduce pollution levels across all types of internal combustion engines on our path to electrification. So I think there's opportunities. I think we have to apply these regulations across all vehicles, not just pick and choose which vehicles, because I think, unfortunately, all vehicles have some type of pollution. Even battery electric vehicles, the pollution is from the source of where you're generating the electricity, depending on the type of electricity generated. But I think that there are so many opportunities, and we have the technology. The challenge is just you've got a lot of very clever engineers at automotive companies and suppliers that can apply the technology. It's a matter of what are the regulations that they're required to meet, and what are the costs that consumers are willing to bear to have clean air. And so I think there's some great opportunities. I think we need to look at things holistically and be quite pragmatic about how we approach things. Another point on electrification, I know in the United States that we have challenges sometime with our electric supply, as much as we hate to admit it. That, California's had some serious issues, Texas. And so, we just need to make sure that we have the infrastructure available, whether it's the electricity generation, the charging stations, and other infrastructure to really make a move if we chose to do that. So I think it's a bright future. I think it's uncertain. And I think we ought to just prepare for, let's clean up the cars we have today while we anticipate, things in the future.
Wonderful, wonderful, Dr. Cutler. We have been receiving quite a few questions from our participating delegates today. I'm going to take a few. We have about 5 minutes left for the session today. Srinivas Matta wants to know, is there any technology under development to control the air pollution due to brake dust?
That's a good question. That's one that has been on the radar for a number of people. I think there are some potential technologies. They're not so simple, But I don't think that any of these technologies will make it to the forefront unless there were things that would require regulations that would require it. So yes, in some instances, actually, the particulate from tires and brakes become much more important, as we move to electrification, because you've got heavier vehicles. And so I think there will be technology, but there would need to be the regulations that would choose, that would require OEMs to implement that technology.
Right. Vignesh S. wants to know, can you please explain about the correction factors involved in correlating a driving cycle, say the Indian driving cycle, with real driving cycle?
Yeah, it's a good question. I think this conformity factor started in Europe, where they would have a regulation, and then they'd say in real world driving, they started with a conformity factor of, say, 1.5. You can emit in your real world driving up to 1.5 times the amount of pollution that you do on this drive cycle. And over time, at least in Europe, this conformity factor continues to shrink, because it's in part based on the ability of the equipment, say the measurement error, and how accurate the equipment is in measuring this real world driving pollution. So I think what we'll find over time is that these conformity factors will continue to shrink. At least they have in Europe, and I suspect in China, and also in India as well, as the measurement technology improves.
Sure. A following question is from Sashank Kumar. He says, very interesting observation about the pollution being created at the start of the IC engine before the system warms up. Do you think in situ gas and temperature sensors within such IC engines could help address pollution issues to some extent? We are building MEMS sensors capable of high temperature operation and very precise analytical grade information capability. Should we think of this as a use case?
I think it's a good question. Certainly, much of the gaseous and particulate takes place in the first couple of minutes of operation. I think the sensor technology is part of the solution here, but I think that it's more a matter of how do I get, catalysts are very effective once they're warm. So how do I get that catalyst warm faster? For Euro 7, there's a talk of adding an electrical heater to the system, which heats that cold gas for the first 2 minutes so that the catalyst starts to behave almost immediately. What we're finding on the particulate side is while the particulate number spikes at the beginning, the only way to capture that is to create, this better microstructure to capture those particles so that they don't break through. So I'm not sure that the sensors will help on the particulate side, but they may be quite useful on the gaseous emission side if we can link them back to the engine control unit or the computer that runs the car.
Wonderful. The next question is from Selva Kumar, who wants to know, could you please tell us about novel materials used for manufacturing DPFs?
Yeah, so most of these materials that are used to manufacture either DPFs, diesel particulate filters, or GPFs, gasoline particulate filters, need to be very low expansion. Because you can imagine that if you get into your car in northern India in a cold morning in winter, maybe it's 0 degrees C, and then in a few minutes, your car exhaust is 600-700 degrees C. And so the types of materials that we have developed have a very low, what we call coefficient of thermal expansion. So it doesn't expand or contract much with temperature. So it remains intact so that the ceramic doesn't thermally shock. And so, you know, it's a special, we have two different materials. One cordierite, which is a magnesium aluminosilicate, and other, which is aluminum titanate. And both of those essentially do not expand and contract much from very low temperatures to very high temperatures, which allows them to be durable over the life of the vehicle through these thousands of, you know, heating and cooling cycles. And so those, we typically use precursors, things that we can mix into the batch. And when we form it into this honeycomb ceramic, goes through a variety of phases and materials on its way to this high temperature thermal shock resistant material.
Right. I'm going to take one final question, Dr. Cutler. This is from Prakash Sardesai. He says, are you a fan of retrofit program when it comes to improving old generators, which have huge engine out particulates and bad maintenance? If a law comes in, will it not only ruin the partial filters as well as DOC if old generator engine cannot be redesigned?
Well, I think the challenge in general, whether it's, you know, old engines, so if you think about a car with an old engine, it produces maybe 50, you know, it pollutes as much as one dirty engine pollutes as much as 50 clean engines. And so when we're thinking about retrofit, it's more difficult, obviously, in a car because of the engine control modules. But if you're talking about generators, I think there's an opportunity depending on the age of the generator. I think I'm a big fan of obviously reducing pollution wherever I can. But I think there are limitations in some engines as to the ability it's not to capture the pollution, but how do you make sure that you're regenerating and cleaning these filters? So, you know, I think we'd have to talk about exactly what vintage we're talking about, but I think there is a place for retrofit and opportunities there. I think it's just not, you know, blanket that one solution fits all.
Dr. Cutler, with that, I'm going to end this dialogue today. Thank you so much for participating in this dialogue and also answering all the questions that we've had for you. Once again, truly appreciate. Thank you.
You're welcome, and thank you for your interest. And if people have other questions, I'm happy to address those offline. So thanks for taking your time.